Okay, the key to doing this challenge question is to know your graphs. If you know your graphs, you can identify the points where cos theta equals 1. And you can think about what those values of theta will be in degrees first. And once you know what they are in degrees, you can convert those degrees into radians. And you're looking to figure out what the sequence is. And in effect, you're going to write down the nth term for the sequence of the x coordinates of all of the red dots that you see on the screen. So these red dots, that's where cos equals 1. And if we go through and change all of our angles, 360, 720, into radians, we get this sequence of radians. So it's the even numbers times by pi, or the nth term for an even number is 2n. So theta equals 2n pi. And that's how you figure it out. Okay, if you didn't get that one, have a go at the next one. For me, it's just more difficult. There is something funny going on in the next one, but you need to do the graph. Okay, I do think this one's more difficult, but you do need to draw the graph and identify the points where sine is -1. If you haven't done that, pause, give that a go. Can you get the values of pi that are going to give sine theta equal to -1? So we're not after sine equaling 1, it has to be -1, which is the minimum points. That's where we have -1 on the y-axis. So our first angle in terms of pi is 3 pi over 2. And if we look at the negative one, just because of symmetry, or no, actually, it's going to be minus pi over 2 because it's minus 90 degrees. You will notice there that we have an odd number in the -1, an odd number in the 3 pi. So there's something going on with odd numbers here, but it's not the same because we've skipped 5 pi over 2. We don't need to do that. But what we can think is we just add 2 pi on to 3 pi over 2. And we could add on another 2 pi to get to our next value of theta. So we could start with 3 pi over 2 and add any multiple of 2 pi, and that will take us to another point on our graph which has -1 as a y value. So if we start at 3 pi over 2 and we add one lot of 2 pi, we end up at 7 over 2. If we added 2 lots of 2 pi, we will end up at the next minimum point. 3 lots of 2 pi, we will go to the next minimum point. So this is a valid answer. If you got something else and you want to check, ping me on Teams. Okay, in the tan question, we are going to be looking at the graph of tan, and undefined basically means either infinity or asymptote. That's what you're thinking about. Where are the asymptotes? That's where you're getting the undefined angles. So we take the same approach. We think about what values those are in degrees, and we convert them into radians, and we create a sequence of points, and we're trying to describe those points with an nth term formula. So our first asymptote happens at 90 degrees, but we want to know what that is in radians. So converting 90 degrees in radians is the first skill. That's pi over 2. Now we know that the tan curve has a period of 180 or pi, so we can just add on pi to go to our next asymptote. And we could add on pi again to go to our next asymptote. And if you do that, you're going to get pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, and so on. What we're writing down here is a sequence of odd numbers times by pi, all over 2. So the answers on the screen is the correct form. If you've got something different and you want to check, please let me know on Teams, send me a picture and I can verify it. Okay, that's the end of the challenge question. Should move on.